Activity 3. Now consider a two-dimensional case of electric potential for which we have plotted equipotential curves. Okay. For this case, do the following. Draw at least 5 electric field lines. Got it. Indicate the direction of electric force for a positive charge. Indicate the electric potential for a negative charge. Would the force on this be different, something, 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 position B. Okay. So we're going to start by drawing at least 5 equipotential lines. So for drawing these, we know these are equipotential. Equipotential basically means equal potential. So at the 150 volt equipotential line, every point on this line is at 150 volts. Same for the 200, same for the 250, and the 100 volts also has 100 volts at the line. So the way you look at equipotential lines for determining electric field is the electric field will be perpendicular to the equipotential lines. So we start by, I'm going to go here, I'm going to draw it like this, the one like, no. So we draw a line like so, where there's right here, 90 degrees. Got it. I'm going to draw another one, also 90 degrees. Okay, I guess that was kind of boring since pretty much going to go straight out. And then this guy, can't really see it, but I'm going to assume, yeah, call that good. Nope, that's you. And then I'm going to draw another one right here like this. But I'm going to adjust it so it is actually more 90 degree-ish. Click. There we go. And we'll say 90 degrees right there. All right, so that's probably the easiest one. So now let's get one that kind of runs through a little bit of curves. So, do another line. Start here. Go there. That might be a little extreme. Not that being extreme is bad. Okay. Another arrow. Yeah, probably about like this. Not as exciting as I'd hoped. Move this guy up here. And 90 degrees from this point. Maybe move him up a little bit. There we go. And you kind of see it's curving out. And then from here, we can do another one. And then this guy would be probably even more up this direction. There we go. And you can see how it kind of has a curve going out. And then you'll do that at every point. All right. So now we have the electric field line. Now we need to find a direction. Electric field lines need a direction. So we have high potential to low potential. So the idea with this is, if you think of it like a topographical map, and we assume positive test charge, the like a mass would roll from high potential, high gravitational potential, to low gravitational potential. A ball would roll from the top of the hill to the bottom of the hill. So a positive test charge will go from here to here. So to get that, we're going to draw the positive and negative signs on here to make that happen. So if we want a positive test charge to go from 250 to 100, we're going to have a plus here and a negative here. That way the positive test charge would be pushed from this point away from this positive charge and this. This is the same idea as I did before, where I have a, whenever I have electric field lines, I draw a kind of like a parallel plates, except these aren't really parallel. I'm going to say that they are mostly parallel. They're not mostly parallel, but I'm going to kind of pretend for this, just so that I can get the concept right. So over here we have negative, over here we have positive. Okay? So, and electric potential is, I refer to it as electric potential energy difference. So up here we'd have a lot of potential energy, because if we had a positive charge here, next to all these positive charges here, it would shoot off in this direction, and it'd take all that potential energy and convert it into kinetic energy. So at this point it would have very little potential energy, but it'd have plenty of kinetic energy to make up for that. All right, so I drew 2 of them, draw some more. Indicate the direction of the electric force a positive charge placed at position A would experience. All right, so now since we did a good job on the first part, this part's easy. So indicate direction of electric force charge at point A would experience. So if you were smart, you draw one of your electric field lines through here. So positive charge would feel it in this direction, towards the negative and away from positive. And then this will be 90 degrees right there. Ooh, I can even draw these in right here. Very nice. Okay? Indicate the direction of electric force a negative charge would feel placed at position A. Okay, I'm going to call this guy positive. I'm going to go to red, just to change it up, call this guy negative. Red's just such a negative color. That's why it causes you trouble when you start working on your car battery. All right. Let's see here. Moving on. Would the force on this negative charge be greater or smaller in magnitude at position B? Okay? So we're comparing A and B. Do they even mention C? Oh well, I guess no one cares about C. I care about the C. The only woman that I'll truly love. All right. Okay, that sounded so happy. So this, I don't like red. We're going to go back to blue. Just like the C. Unless, of course, I guess it's the red C. All right. So we know that voltage equals E negative integral E ds. Therefore, E equals negative divergence, which is kind of like a derivative of voltage. So we're looking for the change in voltage over distance. So to find this change in voltage over distance, we're going to say these are two about the same size, more or less. This has 100 volts change, this has 50 volts change, so this has a higher voltage change per unit distance than this guy. Therefore, it's going to have a stronger electric field, therefore a stronger force. So at B, the magnitude will be larger, and if these are the same size, and one's 100 and one's 50, I'm going to say twice as large. B will have a larger magnitude of force exerted on it than at point A. So would the force of the negative charge be larger or smaller in magnitude at position B? The magnitude would be greater at B. And it doesn't matter if it's negative charge or positive charge, the magnitude will still be the same. The negative or positive just gives you direction, left or right. And that's all we have for part 3, and I will see you on the next part. Thanks.